Hello friends, in today's lecture we are going to study motion in a straight line part 3. Okay, so this is part of chapter number 3 CBSE NCERT for class 11th physics. Okay, so before we start I would like to request one and all to subscribe to our YouTube channel and click on the bell icon to receive the future notifications. So we will start with definition of acceleration. So as we know that when velocity of an object is changing, so it is changing with respect to what? It can change with respect to distance or it can change with respect to time. So which one is more accurate? And how to measure acceleration with respect to distance or with respect to time? So according to experiments conducted by Galileo Galilei, he found that we need to calculate acceleration as rate of change in velocity with respect to time. He did experiments on freely falling body and motion of the body down an inclined plane, and he came to conclusion that we need to measure acceleration as rate of change in velocity with time. Okay, so what is meant by average acceleration? Okay, suppose at time ti a body is moving with instantaneous velocity vi, and at time tf a body is moving with instantaneous velocity vf. So how will you measure acceleration, or how will you measure average acceleration instead? So average acceleration will be measured by change in velocity divided by change in time, that is vf minus bi y tf minus ti. This is the formula. Okay, already we have understood the concept of average velocity and instantaneous velocity in our previous video. In the same line we are having the concept of instantaneous acceleration. So what is instantaneous acceleration? Instantaneous acceleration is the slope of velocity time curve at any instant. Okay, so what is the sign of acceleration? So acceleration can be positive, or acceleration can be negative, or acceleration can be zero as well. Okay, the unit of acceleration is meter per second square, and acceleration is a vector quantity. Why it is a vector quantity? Acceleration is a vector quantity due to the fact that it has magnitude, it has direction, and it obeys vector algebra. That's why acceleration is a vector quantity. Okay, so now we will measure position time curve for different acceleration. We will study position time curve for acceleration 0, position time curve for acceleration positive, and position time curve for acceleration negative. Okay, so when acceleration is 0, we will have two cases. In first case, velocity will be positive, uniform positive velocity, uniform negative velocity, and acceleration as 0. So when we are having acceleration 0 and velocity positive, the position time curve will be a upward sloping curve. This will be the upward sloping curve in case acceleration is 0 and velocity is positive. And in this case also acceleration will be 0, but the curve is downward sloping curve. That means velocity is negative. Okay, so now we are having two more cases. In one case acceleration is positive, small positive, large positive, and in second case we are having acceleration negative. Okay, so when acceleration is small positive, curve will be like this, and when acceleration is large positive, curve will be like this, and when acceleration is large negative, curve will be like this. So we will discuss how it is so. Okay, so we know that velocity is given by tangent to position time curve. So when you will draw the tangent on this position time curve, the slope of the tangent will give us velocity. So on this point, when we will draw the tangent, the slope will be smaller, but as we will move forward with time, slope will increase at an increasing rate. Just see slope here. Slope is increasing at a increasing rate. So velocity is increasing rapidly. So when the velocity is increasing rapidly with time, in that case acceleration will be positive. In this case it will be small positive acceleration. In this case it will be small positive acceleration. Okay, and in this case it will be large positive acceleration using the same concept. Here we are having some velocity and here we are having another velocity, and it is increasing. So we are having large positive acceleration, and in the third case we are having large negative acceleration. Like this is the one tangent, so velocity will be positive and here velocity will be negative, direction will change, so it will be large negative acceleration. So we will also study velocity time curve for varying acceleration. Okay, so velocity time curve, we can have acceleration 0, we can have acceleration positive, and we can have acceleration negative. Okay, when a body is moving with uniform velocity, then acceleration will be 0, and velocity time curve will be a line parallel to time axis with time on the x-axis and velocity being depicted on the y-axis. This is acceleration 0, a body is moving with constant velocity. Okay, so in this case a body is moving along positive x direction, okay, with 0 acceleration. This is the case when a body is moving along positive x direction with positive acceleration. In this case body is moving along positive x direction with negative acceleration or retardation. In this case body is moving along positive x direction up to a point, and then it is moving along negative x direction afterwards. Okay, and acceleration is negative, and this is the case of one bounce. Okay, there is a kink in the curve. Kink means a body is striking the surface and changing its direction, and this is irregular motion. Okay, so we will discuss here. Okay, when body is moving along positive x-axis and the curve is inclined to time axis, velocity time curve is inclined to time axis. In this case the slope of the velocity time curve will be positive, that means acceleration is positive. And in this case a body is moving along positive x direction, but the curve is downward sloping. When the curve is downward sloping, the tangent of the curve will be negative, so it will be constant retardation or negative acceleration. Okay, it is the case when body is thrown upward. So when the body is thrown upward from the ground upwards with some initial velocity, so when the body will reach the highest point, the body will change its direction. So this point is the point when body is coming downward. Before this point the body is going upward, and from this point onward the body is coming downward. Okay, so that means there is change in the direction, and we can see velocity is becoming negative. And this is one bounce case, when ball is thrown downwards and it is bouncing, and this is the case of irregular motion. Okay, so now we will study some more concepts on the basis of different curves. Okay, we will do this thing in the form of question and answer. If somebody is asking what is the area under velocity time curve, area under velocity time curve is called as displacement. Area under velocity time curve is called as displacement. Okay, so second question is that what is the slope of velocity time curve? Slope of velocity time curve is called acceleration. This is also covered. Okay, so now somebody may ask what is the slope of acceleration time, position time and distance time curve. The slope of acceleration time curve is called jerk. the slope of the position time curve is called velocity and slope of the distance time curve is called speed. Okay, so now what are velocity, acceleration, jerk, snap, crackle and pop? Okay, velocity is the rate of change of position with time. Okay, and acceleration is the second derivative of rate of change of position with time, that means d square x by dt square. Okay, jerk is the third derivative, snap is the fourth derivative, crackle is the fifth derivative and pop is the sixth derivative. That means velocity is the rate of change of position with time, acceleration is the rate of change of velocity with time, jerk is the rate of change of acceleration with time, snap is the rate of change of jerk with time, crackle is the rate of change of snap with time and pop is the rate of change of crackle with time. Also we can write velocity is equal to dx by dt, acceleration is equal to d square x by dt square, jerk is equal to d cube x by dt square, snap is equal to d4x by dt square, crackle is the d5x by dt square and pop is d6x by dt square. These are all higher derivative of position. Okay, we mostly study velocity and acceleration and these two things are covered in your book, and jerk, snap, crackle and pop are the higher order derivative of position with time. So now the question arises, what do we mean by sharp kink in position time, velocity time and acceleration time graph? Okay, so whenever we are having a kink in the graph, so at that point it is possible to draw two tangent at that point, and at that point the function is not differentiable. At that point function is not differentiable. So what do you mean by differentiability? Okay, so whenever we are talking about velocity is equal to rate of change of position with time and it is depicted by tangent to position time curve. So if we are having a sharp kink in position time curve, so at that point we can draw two tangent. That means there will be two directions of velocity at the same time. So is it possible in real world? No, it is not possible in real world. So whenever we are having sharp kink in position time, velocity time or acceleration time curve or graph, it means there is some problem in our estimation. It is not possible in our real world. This is all for today. Thank you very much. See you soon in our next video. Thank you.